It's recording.
All right.
So, we get this going?
Yep, recording starting.
Great. So, hello everyone. Welcome to our second workshop from the Code With Us series by Cosmos. We believe that this program is like a first step to bring more developers in the Cosmos ecosystem and hope that the people who are joining today will actually be like the builders from tomorrow. So thank you for joining. The series is a process with participants from different organizations, Tendermint, Interchain, Agoric, Band, CyberDevs, Cosmic, ChainSafe, Confio, and others. They run every 2 weeks, and we are announcing the moderators and workshop titles in advance so that anyone can prepare. We have also created a page under cosmos.network/codewithus, a dedicated page where we are posting all tutorials, workshops, and also recordings from previous sessions. So take a look there, subscribe, and let's get this going. Thank you, Sunny, for joining and for accepting to be our moderator today. And can't wait to see what you have prepared for us.
Cool. Yeah, thank you guys all for coming. I'm going to go ahead and share my screen really quick so that way everyone can know what's going on. Okay, cool. So what we're going to be going over today is in the past workshop, it was really focused on sort of, a lot of the workshops for the Cosmos Escape have been really focused on building modules, like building like functional, like application level modules. And what we're going to be doing today is sort of doing that, but we're going to be we're going to be focusing on a little bit lower level in the Cosmos SDK stack. And this is like from a slide deck I made a while ago for an old workshop. But just to like remind people, just as a quick reminder of sort of the life cycle of a transaction, we'll say. What happens is a transaction, so this block here is a standard TX, and it will come, this transaction, it consists of a couple of things. It consists of the auth data and a bunch of messages. And the transaction, first it gets sent to the antehandler, which can either reject a transaction, which sends it to the trash, or it will approve a transaction, after which the transaction will go on to the next stage, which is the router, where it takes only the messages now. It throws out the auth data, because that's already been approved by the antehandler, and now the messages get passed through the router to the proper handlers for them. And then the handlers sort of do whatever functionality that they want. And typically, most Cosmos setups tend to focus on that third step of how to write handlers and writing modules that sort of, implement handlers and keepers and all that. And so for this workshop, I wanted to do something a little bit different, which is focus on stage 1 and stage 2 of a transaction lifecycle. So what we'll be doing today is, the primary goal today is actually to implement a brand new router. But then we can also, and then if we have time at the end, we can start to put together a new type of anti-handler as well. The router stuff I actually have sort of pre-planned, like I've written it all out and I know it works. If we get time to get to the anti-handler stuff, we'd be writing code from scratch, which will be really fun to do live. So we'll see how that goes. But yeah, to start off, we'll start with the router. So, 1 second. So what we want to do is first we want to look at sort of what does the router do right now. Why is this not loading? Okay. So this is what the router interface in the Cosmos SDK looks like. What it does, and this is the default. This one is the default implementation. You could see that in the Cosmos repo under base app router go. And what the router is it's really just a struct that wraps it's a map, right? It's just a map between strings, which are the routes, and the handlers to send them to. And so what will happen when the route method is called on a particular route. So this route is sort of, if you want to send it to the bank module handler, it will usually just be the string bank. Or if you want to send it to the governance module handler, it will usually just be the string gov. And so, where these strings, the handlers and stuff come from, we know from the previous workshop where, like, when you design the module, you have like the module default name, and you set all the like handler name and the param space name and all that. So that's already done. But what this does is it will, take the path and then return a mapping to the proper handler. And we can see where it's used right here in base app. So what we see is this is the actual this is the section of the Cosmos SDK that actually goes ahead and executes on messages. So what we see is we take a transaction and we sort of iterate over all the messages in that transaction. And if it's a check.tx, we leave because we don't run messages in check.tx. But if not, the first thing we do is we get the message route. So every message type has the route enabled, defined as part of the struct. And then we get the handler to send it to by doing app.router.route. And if the handler is nil, then we exit, which means that if the handler doesn't, if that route doesn't exist on this chain, because the router doesn't know about it. So if I passed it let's say I took a message that was designed for another chain, let's say, I don't know, the Forbold chain, but that message type isn't defined on the Gaia chain. The route, what stops that message from being executed up here? It's that message type that that route will not be registered on the router, and so it will throw right here saying unrecognized message route. If it does find it, it'll go ahead and start to execute. So what we want to do today is we want to go ahead and make a new type of router, something that, and so what we're going to do is we're going to create what I call a toggle router, which means what if we want to be able to turn on and off certain message routes. So let's say, if for people who are involved with the Cosmos Hub launch, we started with the bank module disabled, with sends disabled. We did that sort of in the bank module itself, but it would have been nice if we could just turn on and off the message send route. So if the message send is disabled, every time someone will try to do a send message, and it'll get to the router, and the router will say, oh no, sorry, this route has been completely disabled, so you're not allowed to use this. So how would we go about doing that? Let's go ahead and here's what we'll just go ahead and jump into the code. By the way, if anyone has any questions or anything, please throw them in the Code with Us Discord, or you can unmute yourself on the Zoom and just ask the question as well. That might be simpler, I think. So what we're going to do to start off is let's go ahead and make a new repo wherever you want to build this. I'm going to do it in here, and we're just going to use the standard scaffold tool, which Billy went over in the last workshop. So we can do scaffold app level 1, your GitHub username, and then what you want to call this thing. Let's call it anti-demo. Okay. We've gone ahead and created the folder where we're going to create this, and let's go ahead and open this in our text editor. Okay, great. So using the scaffold app, it's went ahead and created the app, whatever CLI stuff we need, the module folder, and because we use level 1, it sort of connected it to some of the simpler modules such as slashing, staking, governance. And it doesn't include some of the more complex, more recent modules such as upgrade and things like that. But that's fine because that's not what we're really looking for here. So how do we start making a toggle router? So while it's not necessarily like a module in the way we normally think about it, it's not something that has a handler and keeper. There's not really a good place in the SDK to put it. So we're going to actually go ahead and use the X folder, and we can still use a lot of the scaffolding tool from modules. It's just that we end up not using a lot of it, because a lot of the stuff it ends up creating is things like the handler and keeper, which is stuff we don't use. But that's okay. It still helps build a lot of the boilerplate that we still will end up needing, like, you know, defining what the codec looks like, defining param spaces, and whatnot. So what we can do to go ahead and create the module itself is we'll go ahead into our X folder and do scaffold module. Let's see what, okay, scaffold module, the user, which is Sunny97, the repo, which is anti-demo, and we'll call this module Togglerouter. So, okay, great. What we see here is we've created this Togglerouter module now with a bunch of stuff in it. And just to keep this thing simple, let's just go ahead and start by getting rid of a lot of the stuff that we are sort of just not going to need for this presentation, for this module, because it's such sort of a weird module. So the thing is, we don't actually need a keeper in this module, so we're just going to go ahead and delete that entire folder. To be honest, we could go ahead and create like the client libraries like the CLI and REST, but I think most of you are probably already familiar with how to do that. If you're familiar, this is sort of an advanced SDK workshop, and so hopefully you're already familiar with doing that, and that's not going to really give me the focus. It takes a lot of time, so we're just going to not get rid of all the client stuff and specs. Who writes those? Okay, so in the types folder, once again, we're just keep things simple. We're going to get rid of errors, events. We're not defining any sort of message types here, which we'll see why, because instead we're actually going to use the param store as the primary way to interact with this module rather than any defined messages itself. And since we don't have any like client stuff like the REST or CLI, we can also just go ahead and get rid of the querier as well. Okay, so these are the pieces that we're actually going to need to implement. So what are the steps to do this? I wrote them down here just so I have them. So yeah, we've scaffolded, we've deleted all the extra stuff. So let's start with creating the router.go. So this is going to be, this router struct is sort of going to be the replacement for what the keeper generally does in a module. So we can go ahead and do new file and create in the types folder. We'll call it router.go. Can everyone see my screen? Can everyone see, or should I make it a little bit bigger? I'll go ahead and make it a bit bigger.
Yeah, I see it.
Okay, cool. So when we're creating a new router, and what we need to do is when we want to create a new router for the Cosmos SDK, we need to meet the router interface that's defined in the SDK folder, in the Cosmos SDK types folder. You have a router.go. And as I mentioned, the one that's in base app, we can see that, okay, so basically the only two things that the router interface needs is an add route function between the route string and a handler, and then it needs, so this is how you register a new route into this router. Then you need a route function, which is actually, you pass it a route and it gives you back the handler. And we see that the one in base app sort of satisfies an interface. We have the add route function and we have the route function. And so I would say that, instead of starting from scratch, let's just go ahead and copy what's already here in the router.go and use that sort of as a base to begin with. And then we can sort of start adding the additional functionality that we want. So we went ahead and copied this in. Let's just change the package type, of course. Okay, so what are the things that we need to do? What are the changes that are going to happen here? So really, the way we add routes, we don't really want that to change. That's not really going to, compared to the normal router, that's the default router that's in the Cosmos SDK, nothing's changing there. What really the functionality, what's going to change is in the route function. We want it to sort of reject when a route has been disabled. So how would we do that? So we'll start by, let's assume the existence of a function that's like get route disabled. Like, is this route disabled? And so what we can do is we'll say if router.get route disabled, and then we, what would this function have? We would want to pass it the context as usual. Oh, but wait, look, there's no context passed into this one because, the base app, it doesn't really make use of the context. It's sort of what we call a stateless router, but this sort of is a more stateful router. The router depends on things that are in the state, and to access state, you need the SDK context. So let's add the context there. Okay, so if router.get route disabled, context, comma, and the path, the route that we're going to see if it's disabled. If it's disabled, what we want to do is return. Normally, what we'd want to do is, this is sort of, I think, sort of an issue with the router interface in the Cosmos SDK, where really this, I wish it sort of returned a handler and an SDK error, but unfortunately it doesn't. What would be nice is we'd like to say like, okay, return SDK and a handler, SDK.error, but it doesn't. So really the best thing we can do right now is just return nil. And if the route is disabled, then let's return nil, and then, as this app, it will it'll reject the error. The only issue is that the reason the error is going to fail is not correct. It says it's an unrecognized message route, which isn't exactly correct. Really, I think this sort of piece should be returned as part of the router itself, but that requires a change to the interface. So if anyone has looking for something to do after this workshop, maybe make a PR to add returning an error as part of the interface for a router. So for now, but we can get away with just returning nil and knowing that the transaction will fail in that case. Okay, great, we've done that. Now, but this function was just this theoretical function we created. We got to actually go ahead and create that function now. So we're going to go ahead and do function router get route disabled, and it returns a Boolean, whether true or false. Is that route disabled? Now, okay, now we have to decide how is this thing actually going to be implemented. So one thing we could do is we could, if we wanted to, make this router, keep it in the state of this router itself and say like, we can make a thing here called, we can make something like, okay, this is the disabled routes, or, maybe we can put it in a KV. What we really need to do is we need to put it into a KV store. And then this thing is sort of eventually turning into an entire keeper itself. What would be easier is let's actually sort of, and then we have to figure out, write all the transactions of how to edit it, how to add disabled routes, how to re-enable routes and all that. But instead we can do is we can use the param store to do this. And the nice thing with the param store is it makes it very easy for governance to modify what's, if we put the list of disabled routes in the param store, it makes it very easy for governance to update that. And the governance types to do that have already been implemented as part of the param store, the param keeper. So let's go ahead and this function. We're going to start, let's go ahead and actually implement how would we do the params here. So, okay, what are the params? So we go into the params.go that was already generated for us by the scaffolding tool. And so it'll say, okay, what is the name of our params? Let's call this key disabled routes. Let's call, and the byte, what it's going to be called in the param store. The key it's going to use is, let's use, just say disabled routes. Okay, then nothing to do on this function. Here, what we need to do is add the parameters to the param struct. So here we'll say, okay, key param name. So this will be, sorry, what will this be? This will be key disabled routes, string, well, actually this should be key, I don't know why it says that. This should be disabled routes, string, disabled routes. New params, so okay, how do we construct that thing? We'll just pass in disable, oh, sorry, disabled route. It's not a string, right? What it will be is a list of strings. So it'll be a slice of saying, okay, this is the list of all the routes that are disabled, okay? So we can go ahead and, so disabled routes will be a list of strings. So here we can say, okay, create a new one, disabled routes, pass in a list of strings, and a lot of this stuff is filling out the boilerplate that's been created for you by the scaffolding tool. You know, if you want to stringify it, you can just say, okay, toggle router params, and then we can say disabled routes equals %s, and just put p dot disabled routes. Okay. The param set pair. So this is sort of important. This is where we we sort of link the key to the actual parameter itself. So here we're going to link the key param, no, sorry, key disabled routes. So this is the key that we define. This is where it is in the store. We want to link that to the actual parameter itself. So p dot disabled routes. And the other thing that you can see is what does this function actually do? You can pass in the key, the value, but you can also pass in a validator function, basically something to validate the correctness of that the value that's being passed in. You can do some sort of like type checking and whatnot. So let's go ahead and add that. We will want to do that. So we'll say p. We'll add a function here. Params validate disabled routes. And okay, so what would we want to do in here? Just to keep it simpler, I already did save this just because it was a little bit annoying to write. And I'll just copy it from here and I'll walk through it. Okay, so validate disabled routes. What we pass into it is an interface, right? So we don't know, the idea is, you know, someone, because it's coming from a governance proposal, someone could say, oh, I want to set the value of disabled routes, which is supposed to be a list of strings. They could say, I want to set the parameter in the store to 5. Like, what does that even mean? Like, you know, we need to type check this. We don't want people to be able to submit whatever they want. So here, we take in whatever is being passed in, we put it as an interface, so it's just the most general thing possible, anything passed into this, and then we type check it to see, okay, look, is this thing a list of strings? If it's not okay, we can say invalid parameter type. Just, you know, it's not a slice of strings, which is what we expected. You cannot. This fails the check. But if it's okay, then what the other check that we want to do is we want to make sure that they're all alphanumeric, because one of the rules in the SDK is that routes have to be alphanumeric. You can't put, like, you know, slashes and, you know, weird characters. And so luckily in the SDK, there's already this function called is alphanumeric. And so we can just go ahead and reuse that. And so we'll iterate over all the routes that were passed in and say, okay, are they alphanumeric? If not, you know, we just say, we return an error saying invalid route. If not, if everything's fine, then we return nil, because, you know, error is nil. And so what we want to do now here is connect this to that one. So we pass in the validate function that we want. So what is this doing, right? This is saying that so this is sort of the key function in the param go. This is saying that, okay, someone wants to edit the value that's at this key in the param store, change it to something they're going to pass in a params. They want it to be changed to the one that's passed in as disabled routes. And we want to make sure and how do we validate it? We want to make sure that, okay, it's the right type is there and it's all alphanumeric. If this passes, this is what will allow people to modify their params. Okay, cool. So we've gone on how to do that. We've done the router.go basics, and we've modified the param store. So one thing I will just say is when you do the scaffold tool, by default, it implements an interface for param subspaces. But we'll actually see that in the sort of param store of the Cosmos SDK, X in the params module we have here is subspace.go. It also implements this like set function as well, which I'm not quite sure why. Yeah, it implements a set function, and I'm not quite sure why the scaffolding tool doesn't include it as part of the interface it generates for the expected keepers. So I would say just add it. By the way, actually, so I don't know if this has actually been covered in the previous workshop or not, but what expected keepers are. So what they are is when you implement a module that sort of has dependencies on other modules, you don't want to depend on the direct implementations. So let's say, as an example, the governance module depends on the staking module, right? Because currently in the governance module, voting power is distributed to staked token holders. But the problem is there might be, let's say another chain wants to reuse this governance module, but they actually want to modify a little bit of how the staking modules work. Maybe they want to like say, oh, no delegation. It's only like direct ballot, direct, only one validator, or however they want to modify the staking module. But if they modify the staking module, the governance module doesn't work because it depends, on the old staking module. So what we want to do is put these sort of clean interfaces where it says, okay, look, if this governance module, it depends on the staking it depends on a staking module that at least provides me this basic functionality. And so as long as if you change the staking module you're using, but it still at least meets that same functionality and interface, you can the governance module will accept it as a acceptable staking module. So we can see that here in the example here. So let's say you want to create a module that needs to interact with coins, like people's coin, the bank keeper. You don't want to be dependent on the bank keeper in the Cosmos SDK module because, while it's a great, well-defined module, it's changing every 42 minutes. That's not great. What we want is, we can say, okay, it should depend on this bank keeper interface. And the two things that we need from whatever bank keeper is passed in is we need the ability to subtract coins and send coins. So any bank keeper that gives us that functionality, we'll be happy with it. So that's not what we're using here. We're not using the bank keeper. We're using the param subspace, and scaffold tool creates us, so let's say someone wants to implement a new type of param keeper. It's not going to be the one in the Cosmos SDK. As long as it meets this interface of what's expected from a param subspace, it will work. And I'll just say for this functionality, though, I don't see why a new param keeper will not include a set function. So I'm just going to go ahead and add it here because it'll make our life a little bit easier in a few minutes. So, okay, when you want to set something, you do what would be the interface needed from a subspace. We can copy it directly from the param module itself. Okay, so here it takes the context, the key bytes, and the value. Cool. Context, key, value. Okay. Now, so great. We're done with that. We've added the set function to the expected keepers. Now we can go back and finish router.go. So we need to, the goal here is we still want to be able to get route disabled. So now that we have the params store, what we want to do is add that to the router. So we'll say, okay, param subspace, or let's call that param space. And so normally, like I said, we don't want to use param subspace because that will link it direct. See, this now has added us as a dependency of the params module in the Cosmos SDK, which is not necessarily what we want. Instead, we're going to do it as the type that we've assigned in expected keepers, so param subspace, which it's great that param dot subspace satisfies that. And to check that, I believe we can even cast it as that. You can do a var param space, space params dot subspace. Sorry, I don't remember how to do those checks. Okay, so this is how you. So here's one where we want ultimately later, but we can say, okay, var param space subspace equals params dot subspace. Okay, so what this check has basically done for us here is that we've verified that we do the implementation of param subspaces in the params module as and it does satisfy our interface and expected keepers that we wanted. So that's great. Once again, I like to just do it to make sure it works and then comment it out, so that way we don't have that as a dependency for this module, because it's not necessary. It's really just a developer check to make sure that we implemented it correctly. Okay, so we've added the param space. Now what we want to do is we want to add two functions on the router to make it easy for us to get the list of all disabled routes from the param keeper and set all the disabled routes. The get one will need here for get route disabled, so we can just get all the list of all the routes disabled, and then in this function we can look for to check if our specific one is disabled, and then we'll have a set one because it'll come in handy for when we do some of the genesis functions. So okay, let's go ahead and do function router. So let's call this get disabled routes. What we're going to pass in here is the SDK.context. I'm just going to quickly check the Discord to see if there's any questions yet. Nothing yet. Okay. By the way, is this all kind of making sense to people? Is there anything I should slow down? Anyone has any additional questions on any piece? Just please speak out on the Zoom or post it in the Discord or something. Okay, so we can go ahead and get disabled routes, pass in the context, and that's, I think, about it. That's all we need to pass in. And for when we want to get the disabled routes, once again, I have it here, so I'll have to rewrite it. Okay, so we'll create a disabled routes function. It's a list of strings, and we can just do router.param space, use the get function that that's here, and say, okay, pass in the key, this one, and it'll put the value that's in there into this variable we created, and then return the variable. And then we can do the alternative as well. We can say function router, for setting, we can do set disabled routes, context, SDK.context, and here we're gonna pass in a list of disabled routes that we're trying to set. Okay, so router.paramspace. So this is sort of where I was saying, see, this will be useful to have that set function that we define in the interface, so we can just easily do this. Key disabled routes, and yeah, that's it. I think that's how easy that function is, right? Yep, it's one line. Okay, now in this function, get route disabled, we want to see, okay, is this route disabled or not? and we pass in the route. So all we have to do here is simply, okay, let's get disabled routes. Let's use that function we just wrote. So router.get disabled route, pass in the context. Okay, let's go ahead and iterate over all the 4 disabled routes in disabled routes. If disabled route equal, so basically say that, okay, if the thing passed in is the disabled, we're iterating over all of them. If one of them is equal to what we're checking, we say return true. If not, we'll at the end just say return false. So far, so good. So now we have this get route function. I'm just gonna put no lint for all of these. Just we don't got time for comments right now. Cool. And so great. Now that means this function should work as well. So we went ahead and basically implemented everything that's needed here. So we've gone ahead and finished the router.go. Next, what we want to do is the types.genesis.go. So here we go into the Genesis file. Okay, what's in the Genesis state? Okay, so what's going to be in the Genesis state of this module? Basically, the only one thing that we've been working with the entire time, which is disabled routes. And once again, it's going to be a list of strings. If you want to create a new Genesis state, okay, return Genesis state. Oops, should I make this plural? Okay, so the default Genesis state, what do we want the default to be? I think for most chains, the default will be to not have anything disabled, and then governance can enable it if it wants. So it doesn't always have to be governance. It could be something like, if you have a circuit breaker module or something like that, that could also do it. But for the default Genesis state, let's go ahead and return new Genesis state and just pass in an empty string. So by default, it's just empty. And validate Genesis. This is where we can actually just go ahead and reuse the function that we had already written here, the validate disabled routes. So what we can just say is return validate disabled routes and pass in data and pass in the disabled routes that's in there. Great, perfect. That's it for Genesis.go. Next, let's go into this Genesis file. The Genesis.go, that's in sort of the main module function, not in the types folder. So we have init Genesis and export Genesis. So here, so first step would be these sort of take in a keeper, but we're not using keepers here. So let's switch that out for the router that we're dealing with. And same thing here, router. Okay. So when we're given a Genesis state and how do we go ahead and init it? So all we're going to do is we're going to say router dot, we're going to use that set function that we created. Oh, sorry, before we do this, we actually have to set the alias because otherwise this thing is being confused. I can't find the stuff. So, okay, all of this stuff, what do we need from here? Okay, so, we don't need the router key because we're not using it. We don't have a store, we're not using that. We do need the param space key. We don't need query param, so we're not using it. Let me just get rid of all the stuff we're not using. Not using a query, not using a keeper. We do need the Genesis stuff. We need the codec. We're not using a keeper. And one thing we are using is a router. That's the one new thing that we've defined. So in the alias file, let's go ahead and add that types.router. Okay, cool. Now, oh, still have one error on this page. Maybe not. Okay. So yeah, now we can go ahead and find the router here. So in this Genesis folder file, we'll say, in its Genesis, we'll say router.set disabled routes, and we can get that from the Genesis file data that's passed in. So we'll say context data.disabled routes. Great. And we just need to do the opposite for this one is when we want to export Genesis, we want to get all the disabled routes. So we'll say return new Genesis state and just pass in the disabled routes. So get router.get disabled routes, pass in the context, boom, there we are. Genesis.go should be done as well. Alias go, Genesis go. Finally, the last main piece is the module.go. So let's just go ahead and, these are sort of type checks. Let's add them at the end, not now. So, the app module basic, this is the stuff we want to use. So, we'll have the module name, register codec, this is all fine, default Genesis. Okay, all of this is fine. We don't have any rest routes because we actually just went ahead and disabled that folder. So let's just remove that basically. Same thing here. We got rid of all the CLI stuff. It does expect a Cobra command, so we can't just get rid of it, but we'll just go ahead and return nil because we don't have any Cobra commands. Same thing here, return nil. Okay, that module struct itself. So you pass in the basic. So that's like all the stateless stuff, right? The name, the codec, yada, yada. Now this is the stateful app module. So instead of the router, instead of the keeper, we have the router. So let's say router, new app module, you pass in a router. Okay. Names, fine, register and variants, we didn't write any. The route, we don't really have one, but we can't just return empty because that's not going to pass. So, whatever, it'll set up a route and it's not going to be there. It's fine because there's no handler. For return new handler, we're going to return nil. Just get in here, we're just going to, say, we can just leave, doesn't matter because we can implement one. We're going to return nil. Something here, implement it. Okay, in Genesis, this stuff is all fine. Support Genesis is fine. Begin blocker. That's actually one thing sorry, I can get rid of this file. We don't need any of this because, we don't really have anything to put in the begin block. So we're going to trash that file as well. We don't need it, and we'll go ahead and get rid of that. And the end block, whatever, it's fine. That's perfect. Great. This should be a working module as far as I can tell. Now let's see why there's all these errors. Says this thing wasn't defined, but I don't see where it was defined. I think this might be an issue with the VS code, like Golang thing. So let's just reopen that thing. Cool. I think all those errors are mostly gone. Okay, so let's see what are these errors that are popping up. Okay, in the handler.go. Oh, we didn't get rid of the handler. Like I said, we don't have a handler, so let's get rid of that. Trash that. Okay. In the module.go, keeper is not defined. Okay, right? Of course, because we don't have a keeper. Replace that with router. Same thing here. Okay, get disabled routes node. Oh, because we have to actually, expect disabled routes to the string. We get a return value. Disabled routes declared but not used. Oh, it's typo here. And too few. Oh, we need to find the default params. So what we're going to. So here, let's say, yeah, the default will be sort of what we already agreed upon, which is just the list empty string, because nothing will be disabled from the beginning. There we go. And great, I think all of our errors are completed. Now, the only thing that's left to do, though, is add it to the app.go. And this is sort of going to be, it's very similar to how we would add normal modules, with only the basic difference is that we're going to be setting a router. So, all right, when we want to add a new module to an app's app.go, what do? We just first we have the app module basics. So we'll say, oh, well, first we got to import it in the first place. So github.com/sunny97/anti-go /anti-demo/Togglerouter. Okay, we got the Togglerouter there. And here we're going to go ahead and add Togglerouter.app/module basic. Okay. Okay, so here's the module. Oh, I got go. Okay, so we want to add add it to the subspaces. So we'll do app.subspaces, Togglerouter.module name equals app.params, keeper.subspace, and then add the Togglerouter.default param space. Okay. I don't know why this is erroring. Once again, I think this is just something wonky with my VS Code config. Okay, so this is where we define all those modules. So here's the thing. Now, after we define the param space, what we're going to want to do is actually set this to be the router for the module. And the thing is, this is actually a super easy thing to do. So because this function is already actually defined in the base app, we can see base app actually has a function called set router. I don't know why it's not opening. It's opening Chrome. We go to the Cosmos SDK. We look at base app. Helpers. Nope, not in helpers. It is in options. Yeah, okay. So if you look in the base app folder in the Cosmos SDK, in the options folder, we can see that it's actually very simple to create to replace the default router. We just call this set router function. As long as the thing is not sealed, right? And it only gets, so we want to do this after, it has to be done in the app.go. Once the app is started and then it's been sealed, you don't want to be able to change the router mid process. So here, let's just go ahead and do app, because this, we can do app.setRouter, and we're going to use the toggle router we created. So which we haven't created yet, so we need to create that first. Router equals toggle router dot new router. Correct. Let me check my little cheat sheet that I have here. Yeah, router toggle router dot new router. Cool. That should work. And then we can go ahead and do app.setRouter. Great. That should work. And then the only other place we need to add it is the Genesis file. Well, we need to add it to the module manager and then in the init Genesis file. So let's go ahead and add it here. Slashing, so toggle router dot new app module app dot router, or no, that's in the router here, because we defined it as just plain router here. And then Genesis. Okay. This should work now. This is, so let's just go ahead and see if I can restart my VS Code that fixes that import error. And I think it does. So, oh, no, it does not. Why is this being annoying like that? Okay, this, oh, I didn't put the X. My bad. 2897 anti-demo /x/Togglerouter. Great. That should definitely work now, right? New router not declared by package Togglerouter. But it is declared. Oh, we didn't add it to the alias, that's why. So let's go ahead and do that here. So new router equals types dot new router. And now this should be available in the app.go. Cool, perfect, great. And now we can go ahead and check to see that this actually worked. So what can we do? We can go ahead and make install this app that we've created. In the meanwhile, while we wait for this to install, does anyone have any questions about what we've done so far? Okay.
I saw a question in the chat here. I don't know if you got to it.
Oh, no, sorry, what was it?
Oh, in the Zoom.
Where was the question? Oh, I can't, problem is when I'm sharing my screen, I can't see the Zoom chat, which is annoying. So I'm gonna stop the share for a second so I can look at the chat. Okay. Oh yeah, thanks. See, if I was able to Zoom chat, that would have saved a couple of minutes. Thanks for catching that type. Okay, so that we hadn't created it. Let's go ahead and I think it's called appd init, and then whatever the name of the target is, whatever node is, let's call it Sika. Oh, sorry, I probably have one. Let's delete what's already there first. Okay, init Sika. Okay, and then let's go into that folder. Okay, so what's great is we go ahead and open the Genesis file here, and we see the param here for Togglerouter. Togglerouter has been added to a Genesis file, and we say, okay, disable routes, whatever. Let's say we want to start off this chain and say bank transfers are disabled. We can just say, okay, the bank module is not, the bank handler is now disabled, and let's go ahead and start up this chain and confirm that we cannot do bank transfers. And just for demo purposes, so it becomes easier to show, let's go ahead and go JSON. Let's say for governance, let's reduce the time needed, so that way we can make a, well, actually, I don't know if that's worth showing, but okay. Let's go ahead and start the chain. Well, we need to add a Genesis account, so let's look at Billy's old tutorial just because he has all of that written out on how to do that quickly. Okay, so apps UI keys add me. Let's figure out. Okay, let's add a Genesis account. App-d, add Genesis account. UI a key and give it stake. Cool, that should work. And now we should be able to start the chain. No, we should not. Why are we not able to start the chain? Oh, is it because we need to add a Genesis validator? Yes, it is. So let's go ahead and do that. dgentx name. Okay. App-d collect gentx's. Okay, now our Genesis file actually has some gentx's and stuff. And now we should be able to go ahead and start the app. Or maybe not. Okay, so we're getting some sort of error here. And it's actually in the Togglerouter. So let's try to debug this thing. So it's saying that the set disabled routes has an invalid memory address or nil pointer dereference. So in the init Genesis is the problem. So let's in router.go 59. So let's go ahead and jump back into the code to hunt down the bug. Okay, so it said router.go. Keep it bigger for everyone. So the bug is in router.go line 59. Okay, so something's happening here in the param space.set. It's claiming that we are doing a nil pointer dereference. So in the set of param subspace, we are oh, I saw a message. Okay. Okay, let's try to figure out what's happening here. So router.param space. Okay, that's not the issue because that's well defined. Disabled routes. So my worry is maybe this is the problem. So just to confirm, let me look at where I've actually implemented this code already. I know it works. It's in the straight edge repo. So here I do router.paramspace.set context. That all seems exactly the same, except for the fact that we changed the name of the key, but okay. So maybe the problem is in the Genesis file because we have here in the Genesis go. Okay, so set disabled routes data.disabled routes, which is from here. Mhm. So I feel that it thinks that this is coming as nil for some reason. I wonder if maybe it just wasn't. This was somewhere where I forgot to add it, like init the Genesis in the app.go maybe. So we did these ones, did the app module. So we did set the order in your Genesis. Okay, do people want to watch me debug this, or should we go on something else?
I guess quiet audience this time.
Or just because they're muted.
Should we let's see if we can unmute them.
I made it so anyone can unmute themselves.
Okay. Someone asked a question, not sure if you might pass your instance in the router line 155.
Line 155 where? In the app.go?
The person just said, not sure if you might pass your instance. Yes. There you
go. So here, let's see how I wrote it here in this straight edge version. So yeah, here. Oh, no, this is fine. Oh, that's the problem. When we created, if that's what you meant, then yes, good catch. So we went ahead and created this thing, but we didn't pass in the router subspace that we just went ahead and created. So what we're going to do here is pass in this so okay, this is sort of so toggle router subspace. And so here, set that, but then we also need to pass in this subspace into the router. So just how, when you create a keeper, you need to pass in the subspaces you're trying to give it. It's the exact same thing here. And so in this new router function, we also sort of forgot to do that, where here we need to pass in the param space. So param space, subspace. Okay. And then here, okay. Now this once again passes that check and it's commented out, so we don't have that dependency. So these two things here are just the type checks that we talked about. Okay, good catch. Now this should hopefully work. I don't think this is a necessary way. Just keep it simpler. Let's see if we can get rid of that. Okay, there we go. Okay, so after we created the Togglerouter param space, when we create a new Togglerouter, we need to pass in that param space. And now that router looks correctly defined. So let's go ahead and redo this entire thing. So let's do appd unsafe reset all. Let's go ahead and make install this again. We have the new code. Okay. Now, the Genesis file should still be there, fine. Just check to make sure. Yep, okay, so it has the disabled routes there. And now, now let's try to do an apt start. Cool. Parameter disabled routes not registered. Okay, this is something now with well, we did define it. All right, any more helpful hints from the audience? Parameter disabled routes not started, not registered.
So maybe in a codec registration.
The codec registration. Shouldn't that be done by the module manager? I believe so. Let's say so it will go over all the module basics and register the codec, and it is here in the module basics. Yeah, and so we do have the codec here. I don't think there's anything we need to add here. No, it's something about the something where we didn't initialize the param subspace correctly. Togglerouter param. Oh, one thing I would say is that for this Genesis, we probably should have actually set a JSON rule for this instead of calling it disabled routes. I don't think that should. I don't think that's the problem, but that's generally good practice. But what would be the problem? Okay. We have that, we have that. Create the subspace. Oh, of course, sorry. Once again here, we messed up here. We need to do it with the key table because that's what tells it that these are the, so I think I actually even have that in my cheat sheet version. I don't know why I didn't just copy it directly. So we go here, when we do that, when we set it up, where is it? Okay, it's param. So Togglerouter default param space. Oh, don't have it in the cheat sheet version, but basically we need to, while we do it, we need to pass in with the param key table that we created. And that function, maybe change the name a little bit. Param key table. Oh, that's because it's on an alias, that's why. Okay. hopefully that might be the solution. We'll see. So let's go ahead and once again, app unsafe reset all this. Go ahead and make install again. %50 of SDK development is just hunting down annoying stuff like this. Well, maybe that's just 50% of all software development. Okay, let's go ahead and try this again. So clear to start. Okay. Cannot register a param set pair with non-alphanumeric parameter key. Okay, so that at least is probably a bug that's pretty easy to hunt down. I think all that's saying is you can't have that underscore there. So we can just go ahead and get rid of that underscore. And let's just, once again, unsafe reset all, you can install that. Okay, and here we go. Okay, we're making progress. We have more errors. Oh, this is saying this is something wrong with the delivered GenTXs though. So you know what? Let's just go ahead. You don't need a GenTX in order to start an app. We can just go ahead and get rid of that Genesis. Let's just go ahead and recreate the genesis.go anyways. And while we're at it, let's go ahead and, like I said, we should, like good practice, we should really have a JSON definition there, like something similar to this in the genesis.go. So let's go ahead and add that if we're recreating the Genesis. Okay, let's remove the GenTX folder. Okay, so now let's go ahead and start the app again. Appd chain ID equals, I don't know, test, anti-test. Okay, and now we'll go ahead and go into that, add the disabled thing again, disabled routes. Okay. I thought that should have changed, but I don't know why I didn't. Oh, it's because we didn't make install it. Okay, try that again. Okay. Okay, cool. So now at least this that JSON thing is there correctly. Less chance of bugs that way. Okay, so let's add bank to disabled routes, and let's see if we can. We got to add the Genesis account. Okay, we just check to make sure that the Genesis account is added correctly. There we go, we have it. We have the stake that we need. And let's see if this works. The start. Huh. Why is it having error delivering GenTXs when there are no GenTXs? Let's try to create a GenTX again. We have some GenTXs. Now let's see if start. Internal error. That is kind of odd. I wonder if I really don't think this is the issue, but just in case, let's try to move that init genesis. I remember there's like something that's like, oh, no, that doesn't really make sense. Ah, look at that. That was it. Yeah, there's all. So one thing people should note is when you're in the app.go, great, we're making blocks. Nice. Okay. So one thing that people should know is that when you are in the set order, in the app.go, you'll often have something that's, it has something called set order init genesis. You want the gen util module to sort of always be the last module in the system. It sort of, I don't know, it causes weird bugs when it doesn't. It specifically needs to have to always be after, it says here, it has to be after sticking. But I noticed it also causes bugs when, you know, if you're adding new stuff, try to make sure you leave the gen util module as the last one. Otherwise, there are always weird errors like the one. I think like the one we just saw. So good. Okay, we can see blocks now. Okay, so now what's great is we can do, well, let's go ahead and make a, let's make another account really quick. App CLI keys add you. Okay, and so what we're going to try to do is let's make a transaction to go ahead and send some coins. App CLI TX. What is it? Is it just send or bank? Okay, it's called send. TX send. From which key or address? Let's send it from the one that has money, which is me, and let's send it to you, your address, and how much we want to send. Just a small amount that we have. Okay, let's try this. It's probably going to actually say need the chain ID, but maybe not. Let's see. Yep. See, chain ID required but not specified. So ID, I think we set it to anti-demo and confirm for signing and broadcasting. And to be honest, that's not the error I was expecting. Signature verification failed. Oh, maybe we didn't actually set the chain ID correctly. Let's see what we actually set the chain ID to. Anti-test. Okay. Oh, anti-demo. Anti-test. And there we go. It should have failed, but it did not. It actually passed perfectly. That's not right. CLI query account. And actually happened perfectly, which is, or did it? Let's see the account that we sent to. Does it have points? Okay, yeah. See, the send actually didn't happen. This, the fact that it, didn't give an error. Oh, it's because it succeeded in sending the transaction. So it's not going to fail check-TX, right? Because the router, if it goes to the router, it doesn't check the router and check-TX. The fact that it's saying nothing wrong here, that's just saying it successfully made the transaction on chain, but we can actually go ahead and query this transaction itself. We can say app CLI query transaction and trust node. And we can see, okay, look, code 0, it failed. Unknown request, unknown message route. And the fact that it's saying unknown message route, like I said, that's because the router interface, it doesn't allow you to send error. We just have to give it as nil. And that's something that's fixed. But great, that means successfully, yay, we have actually been able to turn off a message route. And now what we can do is, if we want to turn it on, we just have to make a simple param change proposal, which I'm not going to walk through here because I think many people might probably are already familiar with it. Or if you're not, you can just go ahead and you can look at Figment param change proposal documentation. So they have some really good documentation here on how param change proposals work and how you can go ahead and sort of write your own param change proposal. You can also just look on the Cosmos Hub governance module itself, or maybe, sorry, not the governance module, the params module. X params types proposal. In the proposal handler. I don't know. I forgot where exactly it's in the SDK, but you can look at it. It's probably linked to somewhere in Gavin's documentation. But yeah, you can go ahead and make a simple param change proposal, and it will go ahead and you can change it. So governance, you can make a param change proposal to change it to sort of, if you want to re-enable a route, you can just remove it from the list. So we got rid of bank, or if you want to add a new one, you could say, okay, bank's already there. You can say, let's also disable, I don't know, the staking module. So that way, and eventually, this is something that's not in the router right now, but another example of, here's something where you might want to do if you want to add a more customizable router, is maybe you want every message type to have its own router. So currently what happens is, as we saw, all messages with the, all staking module messages, right? They all have their route called staking, and then the dispatching, further dispatching is done in the staking module handler. Maybe what you actually want is the ability to say, okay, this is a staking / delegate is a separate route than staking / I don't know, unbond. So for example, maybe there's a situation where we actually, we don't want to stop people from being able to unbond, right? But maybe there's a reason that we want to say, okay, no, we want to stop people from making further delegation for whatever reason. We want to be able to say, okay, let's just block only the staking delegate route. So that way, staking / undelegate or unbond transactions still go through. And then if you do want to block all staking transactions, maybe you can add something like this. So you could say, okay, staking / star. So this will say, let's block all possible staking transactions. And so this is if you want to take this toggle router concept a little bit farther, this is probably the next logical way to do it, where we add more fine-grained routes here. And how you could do that is you can actually go ahead and so you'll see that in most modules, you'll see that most module messages have, let's choose my favorite module, which is governance. And you'll see that, okay, you know, most messages also have, like the message interface has something called type, and then you have route. So what you can do in your router is you can maybe actually say that it will take the route of a message / then the type of a message. So that way, that's how you can create these like sort of sub routes as I proposed here. And then you can start adding this sort of stuff as well. Yeah, so that, and this, you know, this system would work really well with a circuit breaker module. So, you know, how I proposed was you can use param chains proposals through governance, but what you might also want is, let's say you have a on-chain, you have sort of like a committee. Let's say, you know, the Kaba code base actually has this implemented, where they have a committee, they have this committee system that can like modify very specific governance parameters. And you can make it basically say like, okay, let's say there's a core dev team and you want them to be able to disable a certain route. Say, okay, this core dev team is allowed to disable the bank send route. This is sort of what the circuit breaker is supposed to do. And that way, you know, if there's a bug found or something, you want to be able to disable a route as quickly as possible to prevent exploitation, and then you can reveal a patch. And you know, if you want, you can have it so, you know, the dev team has to put in some stake and say like, okay, you know, we think this is a bug, we want to disable this, and if it turns out, you know, it wasn't, and they were lying, or they were just like doing something, then their deposit gets slashed. So yeah, those are some ideas. So do we have any questions so far on the entire toggle router, or on routers themselves? And once you understand the router, you know, you'll see that things like the query router are implemented in a very similar way, and you can sort of do whatever sort of modifications you want there as well. So, Peter, do you think I should go on to the anti-handler stuff right now? Or I don't know if I have enough time to really make any significant headway into that, or we should save that maybe for a future tutorial?
That is a great question. I would say we have about like 20 minutes left. Do you think you'd have enough time to dive into that just a little bit, or what are your thoughts on that?
What I can do maybe is show the hacky version of this. So, okay, one of the things that, you know, is very, so here's what the goal is. What I want is the ability for someone else to pay your transaction fees. Let's say you want to make a, you know, let's say you want to make a transaction, but you want someone else to pay your fees for you. How would you do this? The simple way is you could say, so there's the complex way, and then there's the simple way. And we'll go over the simple way today. The complex way is you would actually have to modify the anti-handler. But the simple way is you can actually, oh, someone raised their hand. Someone have a question?
Oh yeah, someone asked a question in the chat too, by the way. Zoom chat.
Oh, no question on the router. You seem to have based your session on previous session where you covered transactions. Where can I find these? Yeah, you can, Peter, yeah, maybe you can link her. So last week or maybe 2 weeks ago, Billy Rennekamp, he did a presentation on creating a module. And yeah, you can check out his video. It's great. Much more polished and prepared than mine was. This is like sort of the first time I'm doing this. It's a bit more lower level. So yeah, check out his tutorial. It's really good. Cool. Okay, so let me go ahead and share my screen again. Okay, so what's cool is if you want someone else to pay your transactions for you, we can actually sort of make clever use of this, how standard transactions work in the Cosmos SDK. So if we look in the Cosmos SDK, let's look at the existing anti-handler, right? So we go into the anti.go and we say, okay, let's look at the deduct fee decorator. That's what, this is what, so, how the anti-handler works is it's this sort of chain of functions that get executed. So it's just like, it'll say, okay, first, set up the context, validate basic of the transaction, validate the memo, consume the gas. It sort of does all these steps. And if any individual step fails, it'll reject that transaction. So you basically need to pass, you can think of it as a checklist. So you go down and you return true on all these transactions, then the anti-handler will pass. What's nice with sort of this new modularization we've done of the anti-handler is any module can add this decorator. That's what we call these. A decorator is like the name for this sort of checklist item. And any new module can sort of say, hey, I want to add something to the anti-handler. And it can define a decorator, and then in your app.go, you can go ahead and add it to add the decorators from different modules into the chained anti-handler. And so in a future presentation, I'll probably go over actually creating a anti-handler decorator. But for now, let's just make clever use of an existing decorator. And so what we're going to do is we're going to look at the deduct fee. Actually, also what we will look at is in the auth module, I believe it's in here. So if you go to types, standard TX, okay, so you'll notice what happens here is, so a transaction can have multiple signers. So let's say you have a message let's say you have a Cosmos SDK swap message where, this transaction, it moves BTC from my account to your account, and it moves atoms from your account to my account. You can make it so that this transaction, this message type needs the signatures of both addresses that are participating in the swap. If you can't just have one person's address and not the other, then the swap won't go through. And obviously, as we mentioned, a standard transaction will have multiple messages. It'll have a slice of messages. So when it has a slice of messages, it basically takes the union of all the required signers of each message. So because the SDK.message type, each message has to say, these are the signers for my message. So let's say you have two messages, the first one requires Alice to sign, and the second message requires both Alice and Bob to sign. The get signers of the entire transaction, it'll require Alice and Bob. It'll basically concatenate the two and get rid of any repeats. What's interesting is that's true for the get signers, but when it comes to fee payment on the SDK, we actually have made it so only the first signer has to pay the fee. No one else is paying the fee. And we did this for some efficiency reasons that I'm not going to get into, where you just don't want to, you want to minimize the amount of computation you do in the anti-handler, because the more computation there is in the anti-handler, the higher of a spam vector there is. And so if you allow multiple people to pay the fees in the transaction, that could potentially be a large spam vector. So instead, what we want is we say, okay, let's only make it, so we say, okay, who's the fee payer for the transaction? We get the signers, and it's only the first person in transaction. So what we can do is we can actually, if we want to make it so we can say someone else wants to pay the fee for my transaction, we can just insert a dummy message in the beginning of the transaction where all it does is change the it just adds someone else as a signer. And that way, if they're the first signer, they'll be the ones who are paying the fee. So let's say I want to send a transaction to Peter, but normally in a bank send, it's the person who's sending money who's paying the transaction fee. But I don't know, maybe I'm like, why am I paying the fee to give you money? Peter, I want you to pay the transaction fee. So what we can do is insert a dummy transaction or a dummy message. So this will be a standard TX with two messages. The first one will be this dummy message that just sets Peter as a signer, and then the second one will be my send of money to Peter. Now this transaction requires two signers, both myself and Peter, but Peter is the first one, and so he becomes the fee payer. So this is sort of a clever hack you can do around just sort of making use of the fact of how the standard TX, the default anti-handler works in order to change the fee pair. The issue here is that Peter then does have to be a signer of the transaction. What will be which is, maybe it makes sense for this use case because he's paying fees. But if you want to get into something more complex, you actually will want to go into sort of the ability for maybe Peter wants to give me a fee allowance or something, saying, oh, I'm allowed to pay, let's say you're within an organization and, the company gives you like saying, okay, here, you will pay your fees up to like this amount per month or something, it's like your budget. So that's where we'd want to do. And I wrote a spec for this a while ago, and it's been iterated on like a number of times by a number of people. I think some of them are even in this video call. But I don't know, to be honest, I'm not sure what the status of the implementation is, but this is sort of a simple hacky way around it where, as long as the person who is agreeing to pay the fees is also a signer, then they will also, it's very easy to make them pay the fees. And, just to show it, since we have like 15 minutes, let's just go ahead and actually implement this model. So what we can do, scaffold, module, demo, and let's call this add signers. That'll be the name of our module. Okay, let's open this up in our text editor. Okay, we're done with toggle routing. Close all this stuff. Okay, so in the add signers, once again, let's get rid of all the stuff we don't need. So, we don't have any client stuff. We don't have any keepers on this module. It's just this dummy module. Types, we will need a codec still. Errors, we don't really need any there. We could do an event. So let's keep that file if we decide to get to that. There's really no expected keepers we need. We're not using the param subspace or anything. There's nothing to add in Genesis. Keep that, add signers. Okay, so this is where magic will come in the message.go. So what we'll do here is we will go ahead and first let's uncomment all of this. Okay, so what we'll call this, let's call this message add signers. Message add signers. So who are the signers? So let's add signers and let's make it a slice of sdk.account address. Added signers. Okay, new message. Let's go ahead and just fill that in over here. Okay, new message add signers. Okay. This is sort of the name of the action. So let's call this. Okay. So here, who are the signers in this? We're just going to go ahead and return message signers. Get sign bytes, validate basic. Okay, what do we want to put in the validate basic here? Let's make sure that the slice isn't empty. So if when sorry. Oh, oops. Gotta fill those in here as well. Okay, so if message.signers, if length of message signers is 0, then return, let's create a new error, execute errors dot new, let me just find where I actually have this already written down so I don't have to rewrite the error from scratch myself right now. Okay, so we can just go ahead and just copy this entire function. So for this validate basic, what we can just do is say, okay, look, if the length of signers is 0, let's just return an error. And then let's iterate over all the signers and make sure that the signer isn't empty, because if it is empty, let's return the error and saying this is an invalid address. And great, that's simple, super easy, done. Let's turn off the don't have any params, you don't have any queryers, we don't have anything in the Genesis. What we do have to do is a handler, because if this thing doesn't have a handler, as we learned from the router thing, it'll return nil and it will throw the transaction. So really what we just need here is a dummy handler. So we can just go ahead and say here, case message, add signers, and return handle message add signers, context. We don't even really have a keeper here, so don't even need that message. And then here we'll just do handle message add signers, no keeper, just pass in the message. And we basically don't even need any of this. We're just gonna, there's nothing to do. We just return stk.result and nil. Isn't this just the simplest, most easiest module you've ever seen? And yeah, I'm not gonna go through all of this, where we can just go ahead and, like I said, just delete all the stuff we don't need, yada, yada, yada. You guys are probably familiar enough with how to do that at this point. And what's cool now is you can go ahead and, if you want to change the signer, you just create a multi-message transaction and you insert this message type at the front. And I could say, I would add, Peter as the signer, and then he becomes the fee payer in this transaction. Yeah, I think that's about it, all that I have. Like I said, that was a super simple way to change the fee payer. In the next time we do this, we'll go through creating a much more complex one where Peter maybe is my employer and he wants to give me an allowance and saying, okay, you can pay up to, you can deduct up to 50 atoms per month from my account in order to pay fees. But then that requires some changes to standard TX and the anti-handler itself. So we'll go over that another time. So yeah, that's it for me. So thank you guys for listening. I don't know if does anyone have any more questions over what we discussed over the routers or just generic questions about anti-handlers?
We have a question in the chat. I don't know if we answered this one from Sai. He asked how smart contracts are used here. How smart contract engine is used here. I believe you were in the middle of the presentation back then.
I see. Sorry, what do you mean by smart contract engine?
So in the repo, you mentioned a smart contract engine is used in a straight edge repo, right?
Yes.
So in the new routers, yeah.
So in the straight edge repo, I actually use CosmWasm. So the straight edge repo. So basically, the straight edge repo is like it's a relatively simple module. There's basically three things that have been done here. One is it imports Gaia. It's similar to Gaia, except the three things it does is it imports WASM. So I had to do some stuff to, I think this is actually using older version of CosmWasm. It needs to be updated. It implements the Togglerouter. And then the last thing it actually does, which is probably the most interesting, which is the topic for a future workshop, is I add a new signature type where, because I add the ability to support, so traditionally Gaia supports SecP256K1 keys, and it supports ED25519. But here I wanted to add support for a new key type, which is the SR25519, which is sort of this like custom new key type that Parity had created for Polkadot. And so I want to be able to reuse those keys here as well. And so for future demo, we'll walk through how to add your own custom cryptography. Well, never write your own crypto. Use crypto libraries created by someone else, but how to import them in to be usable into the Cosmos SDK. Yeah, and so how CosmWasm is used here, though, it's just, there's nothing really special about the straight edge stuff, but you can check out cosmwasm.com. This is, it's WebAssembly based smart contracting. They have a lot of really great demos and everything. I believe Ethan Fry is the main developer of CosmWasm, and I believe he's actually doing a Code With Us workshop very soon on how to use CosmWasm to create tokens. So yeah, check that out if you're interested in the smart contract stuff. Oh, oops, I just realized I wasn't showing my screen there and I was like walking through stuff, but sorry if that was kind of complex to see without my screen share. This is what I was talking about. Here's the straight edge repo, and this is sort of like, adding new custom cryptography. And this is the CosmWasm website. Cool. Anything else?
Nice. I think that's very helpful, Sunny. Also, the Terra team is using CosmWasm already. So we're starting to see some adoption with that. And you're right, Ethan, we'll be having another workshop later. So that should be pretty exciting.
And if there's anything people are interested in learning about, let us know so we can create a workshop around it. So I don't know, I decided to do something on the router and anti-handler because I figure it's something that is kind of under explained. A lot of the other workshops focus on other parts of the stack. But if there's anything else you guys are sort of interested in, whether it has to do okay, how would I customize the anti-handler to do X, or sort of anything in the SDK, let us know so that way we can design a workshop that's actually based on stuff that people are interested in.
Yep. I believe also Michelle took a survey too, right, Adriana, on that?
Yeah, she did. So we are looking forward to see the results on the survey. And also if people have like auto proposals on what we should put in the following workshops, please write us like in Telegram or in the special call with us on Discord channel. I'll be happy to listen to what the community wants and adapt some workshops on that particular subject also for the future. So let us know. Thank you.
Sweet, thank you guys. Should I just end this?
Yeah, I think you can end the recording. And thank you everybody for attending. Really appreciate it.
Thank you.